This section is a combination of section 5.2 and 5.3 in the book, and we'll be focusing on the graphs of sine and cosine. So far, we've defined what trig functions are in terms of ratios of triangles. Let's go ahead and review this definition. The first thing that we defined was that terminal points are defined by angles. Recall that a terminal point is a point on the unit circle. So if we had this green point on our unit circle, we could associate an angle to it. Let's go ahead and call this angle theta. Now, the second thing that we can note is that angles determine right triangles and also reference angles. To determine a right triangle using an angle, what we can do is we can use the coordinates of our terminal point to come up with the height of our triangle and the base of our triangle. The reference angle is the angle between the terminal ray of our angle theta and the closest x-axis. In this picture, here would be our reference angle. Let's go ahead and draw this right triangle a little neater. This right triangle, whose terminal point lies on the unit circle, has height y and base x, and whose hypotenuse is given by r, which in this case is 1, since the terminal point lies on the unit circle. Now that we have 1 and 2, we can define trig functions as ratios of the sides of these right triangles. Let's go ahead and recall the definitions for each of our trig functions. We'll start with sine, cosine, and tan theta. Sine was defined to be opposite divided by the hypotenuse. Cosine was defined to be the base divided by, again, the hypotenuse. And tan was defined to be opposite divided by adjacent. While we can go ahead and define what cosecant, secant, and cotangent is, we can also remember the relationship between sine, cosine, and tan, and cosecant, secant, and cotan. Cosecant theta is equal to 1 divided by sine theta. Secant theta is equal to 1 divided by cosine theta. And cotan theta is equal to 1 divided by tan theta. So using the unit circle and triangles defined by the unit circle, we came up with our definition of trig functions. Let's go ahead and write down some notes that are associated to these trig functions. Note number 1. Again, the sign of your trig functions determined by where your terminal point is on the Euclidean plane, whether it's in the first, second, third, or fourth quadrant. Another way to remember this is by the following memory device. All students take calculus. And what this is saying is that all trig functions are positive in the first quadrant. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And then finally, in the fourth quadrant, only cosine is positive. While it's not necessary to use this memory device, it does come in handy. Note number 2. The definition of a reference angle is the coterminal angle that's between 0 and 2 pi. For example, let's go ahead and find the coterminal angle for negative 8 pi divided by 9. First, we'll go ahead and draw the angle. Since negative 8 pi divided by 9 is not quite as negative pi, this is going to lie in the third quadrant, since negative angles go in the clockwise direction. Then the distance in the negative direction from this terminal ray here and our negative x-axis is only given by a negative pi divided by 9. This means that the coterminal angle is going to be equal to pi divided by 9. The third thing that we'd like to recall is our special triangles. We had two types of special triangles, a 45, 45, 90 triangle, whose sides were given by the square root of 2 divided by 2, the square root of 2 divided by 2, and this side of 1. And we also had another special triangle, the 30, 60, 90, whose sides were given by the following. 1/2 was across from 30 degrees, square root of 3 divided by 2 was across from 60 degrees, and 1 was across from 90 degrees. These special triangles are very useful when we want to evaluate trig functions without plugging them into a calculator, because many common values in our trig functions can be derived from these angles, either 45, 30, or 60. Now in this section, we'll focus on studying the graphs of sine and cosine, but we'll also be looking at properties of trig functions in general, such as how do transformations affect sine and cosine, and which trig functions are even and which trig functions are odd. So after this review, the rest of this section is broken down into three main parts. In part A, we'll go ahead and look at the graph of sine and cosine. In part B, we'll be looking at how transformations affect these functions. And then finally in part C, we'll be looking at when our trig functions are even and when they're odd.